As the charge increases, ionic radii decreases. Therefore, charge and ionic radii are inversely proportional to each other. After removal of one electron from chromium, it attains 3d5 electronic configuration. It gains extra stability. Therefore, its ionization energy becomes low. Minimum oxidation state is the number of electrons present in 4s orbital. Maximum oxidation state is the total number of electrons present in both 4s orbital as well as what? 3d orbital. Hello, my dear students. I am Renuka Ashok, the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear students, today I am going to explain the second session of chapter D and F block elements. In the previous session, that is in the first session, I had given introduction to D and F block elements, where exactly situated in the long form of periodic table, and I had given what's the definition for D block elements. D block elements are those which containing partially filled D subshell, either in their atomic state or in their oxidation state. Then I explained the general electronic configuration of D block elements, as well as character of transition elements and variation of atomic size of this transition elements, variation of the atomic size. For example, so I explained about 3D series. In 3D series, as atomic number increases, atomic size decreases first, then it becomes minimum, and finally it increases because of by taking two concepts like effective nuclear charge as well as screening effect, Today, in this session, last class I discussed about atomic radii. Or atomic size. This class, I am going to discuss about ionic radii. And trends in properties of transition metals of first series. First series means 3D series. First series means what? 3D series. What's the trend in properties of transition element? Trends in properties of transition element in 3D series. 3D series is also called as first series. Next, oxidation states. Oxidation state. Therefore, today in this session, I am going to deal with ionic radii and trends in property of transition metals in the first series, that is what? 3D series. Last, I am going to discuss about oxidation state. First one, ionic radii. Ionic radii follows the same trend as that of atomic radii, as along the period, ionic radii decreases. Okay, along the period, ionic radii decreases because of the increase in the effective nuclear charge. So, the ionic radii follow the same trend as the atomic radii. Ionic radii follows the same trend of the atomic radii. Okay. For the same oxidation state, ionic radii generally decreases as the atomic number increases. As the atomic number increases, ionic radii decreases. As atomic number increases, ionic radii decreases in a particular transition series. In transition series, we have 4 series: 3D series, 4D series, 5D series as well as 6D series. 3D series is also called as first series. 4D is called as second series. First series, second series, third series as well as what? Fourth series. 3D, 4D, 5D, 6D. 3D, 4D, 5D, 6D. For example, I'll consider some of the ions which differ with respect to the oxidation state. For example, I'll consider iron in ferrous state as well as ferric state. Iron Fe2 plus as well as Fe3 plus. Nickel in +2 oxidation state and +3 oxidation state. Manganese +2 oxidation state and +3 oxidation state. Observe, here was the oxidation state of iron +2, here the oxidation state of iron is +3, nickel +2, here nickel +3, manganese +2, manganese +3. Observe, as their charge on the ion increases, its ionic radii decreases. Therefore, please note this important key point. For the element in the ionic radii decreases with increase in the charge of the ion. Okay, as the charge increases, ionic radii decreases. Therefore, charge and ionic radii are inversely proportional to each other. So, for that, I had given 3 examples. Iron in +2 oxidation state, what is its ionic radii? 76 picometer. So, for same iron in +3 oxidation state, what is its ionic radii? 64 picometer. Nickel in +2 oxidation state, what is its ionic radii? 72 picometer. Nickel in +3 oxidation state, what is its oxidation state? 62. Manganese in +2 oxidation state, 80 picometer, +3 oxidation state, this is 66 picometer. Therefore, for the same element, as the charge of the ion increases, its ionic radii decreases. Ionic radii decreases, and along the transition series, as atomic number increases, ionic radii decreases. Ionic radii decreases. When I consider density, next topic, density. As you know, all metals have high density. Within a period, the density vary inversely with atomic radii. That is, density increases along the period. Also, density increases upon descending down the group. Densities are increases along the period. Why along the period density increases? Because density is equal to mass by volume. Mass by volume. This density is equal to mass by volume. Here, the volume of the atomic volumes of the transition elements, decreases, or atomic volume of the transition elements becomes low. Why the atomic radius of the transition element decreases or it will become low antadre? Electrons are added in n-1d subshell. They added to n-1d subshell, not to ns subshell. n-1d subshell is also called as penultimate shell. It is also called as what? Penultimate shell. Therefore, when the electrons are added into penultimate shell, there is increase in the nuclear charge. When nuclear charge is partly screened by d electron, outer electrons are strongly attracted by the nucleus. Moreover, the electrons are added in the inner orbital. Consequently, densities of transition metals are high. So, here when the electrons are added to the penultimate shell or n-1d subshell, their density increases. Its density increases. Therefore, metals always have high density. But the densities are vary inversely with atomic radii. Densities increases along the period. Why density increases along the period? Because its atomic volume becomes low. As atomic volume becomes low, the density increases. Next, metallic character. When you consider all transition series, all transition elements in the first row are metals. First row is called as 3D series or first transition series. In 3D series or first trend, it starts from scandium to zinc. So many known metals are present in 3D series. Already know that the known metals are manganese, iron, cobalt, nickel, copper, zinc. All are belongs to what? 3D series. Scandium with atomic number, this is 21, titanium 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, copper 29, zinc 30. It is atomic number. So, they exhibit typical metallic properties like what are the typical metallic properties? Metallic luster, high density, high melting point and what? Boiling point, malleability, ductility, high tensile strength, hardness, brittleness, high thermal and electrical conductivity. 3D, the metals which are present in the first row or in 3D series or in the first series, they shows all typical metallic properties. What are the all typical metallic property? They exhibit typical metallic properties like metallic luster, high density, high melting point and boiling point, malleability, ductility, high tensile strength, hardness, brittleness, high thermal conductivity. And they exhibit all the three types of structures like CCP, closed cubic packing, FCC, face centered, and HCP, and what? Body centered cubic. Body centered cubic. They exhibit three typical metallic structure. They exhibit three typical metallic structures like FCC, BCC, HCP. FCC means face centered cubic. Face centered cubic. BCC, body centered cubic. HCP, hexagonal close packing. Hexagonal close packing. So therefore, all the transition metals which belongs to first row or 3D series or first series, they show all typical metallic properties and they have three typical metallic structures like first one FCC, second one BCC, third one as well as it is known as what? HCP. HCP. Next property is ionization enthalpy. Ionization enthalpy. What is ionization enthalpy or ionization energy or ionization potential? Ionization enthalpy, ionization energy or ionization potential is the energy required to remove an electron from outermost shell of isolated gaseous atom. Isolated gaseous atom. So, the electron which is present in the outermost shell of the isolated gaseous atom, if you want to remove that electron, it requires certain amount of energy. That energy is called as ionization enthalpy or ionization energy or ionization potential. This ionization enthalpy increases in the series as the atomic number increases. As the atomic number increases, ionization enthalpy also increases along the period. However, the increase is not regular because of the effect of increase in effective nuclear charge somehow neutralized by increasing in shielding effect of what? 3D series. For example, when you consider scandium, titanium and vanadium, scandium, titanium, vanadium, chromium, their first ionization enthalpy is fairly close to each other. Observe here, scandium is 631, titanium is 656, vanadium is 650, chromium is 652. They are almost all same, almost all same. So, similarly, iron, cobalt, nickel, copper, this is also almost all same, almost all same. So, when you consider these four metals first, their ionization enthalpy almost all same. Next four metals also their ionization enthalpy is almost all same. The slight variation which occur in these values are mainly due to the slight changes in atomic radii. Therefore, ionization enthalpy increases along the period as atomic number increases. This increase is not regular because of the effect of increasing effective nuclear charge. Increasing effective nuclear charge. Okay. The value of first ionization enthalpy of chromium is lower than expected because the chromium, when you consider chromium, the electronic configuration is AR 4s1 3d5. AR 4s1 3d5 was the electronic configuration of chromium. Argon 3d5 4s1. What is the meaning of first ionization enthalpy? First ionization enthalpy means we have to remove the first electron which is present in the outermost shell. If I remove this electron from the outermost shell, the chromium electronic configuration become AR 4s0 3d5. AR 4s0 3d5. The first ionization enthalpy of chromium, because as you remove one electron from chromium, it attains a 3d5 electronic configuration. 3d5 electronic configuration. This is stable configuration and it gains extra stability. Therefore, its first ionization enthalpy is low. So, the chromium first ionization enthalpy is low because after removal of one electron from chromium, it attains 3d5 electronic configuration. It gains extra stability. Therefore, its ionization energy becomes low. Similarly, Similarly, the value of zinc appreciable higher due to the additional stability associated with completely filled. When you consider zinc, whose electronic configuration is AR 4s2 3d10. Here also configuration, here also the values appreciable higher due to the presence of 3d10 in zinc. The second ionization enthalpy of chromium and copper are unusually high because the electron is now to be removed from very stable configuration, that is Cr plus which 3d5 half filled and Cu plus which is 3d10. Okay, we have to remove electron from half filled 3d5 as well as half filled 3d10. The value of second ionization enthalpy of zinc is comparatively low as it involves, if you remove 2 electrons from zinc, so electron result in the production of involving what? 3d10 configuration. Similarly, second ionization energy of manganese less than that of iron. This is because removal of second electron in manganese produces half-filled D5 configuration. Half-filled D5 configuration. Therefore, ionization energies becomes low when the elements attain D5 configuration. D5 configuration. So, therefore, once again I will tell, first ionization enthalpy for chromium is lower than expected. This is because of the removal of one electron produces extra stable D5 configuration. The value of zinc is appreciably higher due to the additional stability associated with completely filled 3D level in zinc. The second ionization enthalpies of chromium and copper are unusually high because the electron is now to be removed from very stable configuration, that is Cr plus which is 3D5 configuration, Cu plus which is 3D10 configuration. The value of second ionization enthalpy for zinc is comparatively low as this involves the removal of electron which results in the production of Zn2 plus having stable 3d10 configuration. Having 3d10 configuration. Now, oxidation states. When you consider 3D series or any series in transition metals, the first member and last member, first member as well as what? Last member. So, last member as well as first member does not exhibit the variable oxidation state, first and last. Other metal exhibits variable oxidation states. Other members exhibits variable oxidation state. All the elements except the last member exhibit variable oxidation. All these elements being metal give only positive oxidation state. The reason for giving different oxidation state is as that the energy difference between the 4s electrons as well as 3d electron is very small. The energy difference between 4s electron and 3d electron is very, very small. Hence, 3d electron acquire little energy to get promoted to the valence shell. As such, they can be easily promoted to the valence shell. Therefore, they are also involved in bonding. One sentence you can say the variable oxidation states of 3D series because of the involvement of both the electrons which are present in ns orbital as well as n-1d orbital. The electrons which are present in the ns orbital as well as in n-1d orbital, both the electrons are involved in what? Bonding. Because of that reason, 3D series elements exhibits variable oxidation state as well as the first member as well as last member of 3D series does not exhibits variable oxidation state. Rest of the metals, they exhibits variable oxidation state because of the involvement of electrons which are present in both ns orbital as well as n-1d orbital. Now, the oxidation states of these elements. When I consider number of electrons present in the outermost shell is nothing but 4s or ns. Number of unpaired electron present in d orbital of penultimate shell, that is 3dr. 3d, it is 4s. 4s is called as what? Outermost shell. 3d is called as what? Penultimate shell. Penultimate shell. What is the meaning of penultimate shell? Penultimate shell means last but one. So, the oxidation state of this 3d series depends upon two factors. One is number of electron present in the outermost shell. Number of electron present in the outermost shell, that is ns shell, as well as number of electron present in inner d orbital, that is penultimate shell or a 3d subshell. Okay. Minimum oxidation oxidation state is the number of electrons in 4s. Please remember, my dear student, minimum oxidation state is the number of electron present in 4s orbital. Number of electron present in 4s orbital. Maximum oxidation state is the number of unpaired electron present in 3d as well as number of electron present in 4s. If you want to find out the minimum oxidation state as well as maximum oxidation state. Minimum oxidation state is the number of electron present in 4s orbital. Maximum oxidation state is the total number of electron present in both 4s orbital as well as what? 3d orbital. 4s orbital plus 3d orbital, that electron is nothing but what? Maximum oxidation state. Minimum oxidation state is the number of electrons which is present in 4s orbital. Now you consider scandium. If you add electrons in 3d, 1 plus 2 plus 3. Therefore, scandium is the first member of 3d series. It exhibits only one oxidation state plus 3. Now, titanium. So, which is the number of electron present in 4s? 2. Therefore, that is minimum oxidation state. Plus, when you add this 2 plus 2, 4, that is maximum oxidation state. In between plus 2 and plus 3, there comes which one? Plus 3. Therefore, what's the oxidation state of titanium? The oxidation state of titanium is minimum is plus 2, maximum is plus 4, in between it is plus 3. How can you say the minimum oxidation is plus 2? Because number of electron present in 4s is 2 and total number of electron present in 3d and 4s is what? 4. Next, the number of electron present in 4s is plus 2. If you add 3 and 2, it will become what? Plus 5. In between plus 3 and plus 4. Therefore, vanadium exhibits 4 oxidation state, plus 2, plus 3, plus 4, plus 5. Here, chromium, so total 5 plus 6, maximum oxidation state is plus 6, it is plus 2, plus 3, plus 4, plus 5, plus 6. Here minimum is plus 2, maximum 5 plus 2, 7, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. Here iron plus 2, plus 3, plus 4, plus 6. Cobalt plus 2 plus 3 plus 4, nickel plus 2 plus 3 plus 4, copper plus 1 and plus 2, cuprous and cupric. Last member zinc, it exhibits only one oxidation state plus 2. Scandium exhibits only one oxidation state plus 3. Zinc exhibits only one oxidation state plus 2. Therefore, so maximum oxidation state is shown by manganese. Maximum oxidation state shown by manganese. In which series? 3D series. In 3D series, there are how many elements? 10 element. First member is scandium, last member is zinc. Scandium exhibits only one oxidation state plus 3. Zinc exhibits only one oxidation state plus 2. Similarly, next titanium exhibits 3 oxidation state plus 2 plus 3 plus 4. Vanadium exhibits 4 oxidation state plus 2 plus 3 plus 4 plus 5. Chromium exhibits 5 oxidation state plus 2 plus 3 plus 4 plus 5 plus 6. Manganese exhibits 5 oxidation state plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Iron plus 2 plus 3 plus 4 plus 6. Cobalt plus 2 plus 3 plus 4. Nickel plus 2 plus 3 plus 4. Copper plus 1 plus 2. Zinc plus 2. This is about what? Oxidation state. The relative stability of various oxidation state of given element can be explained on the basis of rule of extra stability, according to which D0, D5, D10. D0 means empty d orbital, D5 means half filled d orbital, D10 means completely filled d orbital. They gains extra stability. Therefore, D0, D5 as well as D10 configuration, they have extra stability. Hence, the ions which have these configuration are more stable. For example, titanium in its 4 plus oxidation state, titanium in 4 plus oxidation state, they have empty d orbital, 3d0. Other same titanium 3 plus, it has 3d1, Mn2 plus 3d5, Mn3 plus it is 3d4, Fe3 plus 3d5, Fe2 plus 3d6. So the stability is titanium 4 plus is more stable than titanium in plus 3 oxidation state, because in plus 4 oxidation state it has empty 3d orbital, it has empty 3d orbital. And manganese in +2 oxidation state more stable than manganese in +3 oxidation state, because in manganese in +2 oxidation state it has half-filled 3d orbital, half-filled 3d orbital. Iron in +3 oxidation state is more than iron in +2 oxidation state. In iron in +3 oxidation state it is half-filled 3d orbital. Therefore, any element gains extra stability in its which electronic configuration? D0, D5, D10. D0 means empty d orbital, D5 means half filled d orbital, D10 means what? Completely filled d orbital. Therefore, today in this session, my dear student, I discussed about ionic radii as well as the main topic, that is oxidation state. In the next session, I am going to discuss about magnetic property, colored compounds, catalytic property, formation of interstitial compounds, as well as what? Alloy formation. Therefore, next class I will come up with new 5 concepts like magnetic property, catalytic property, how it will form complex formation, interstitial compounds, as well as alloy. Until that, goodbye. Thank you, my dear students.